So for this last question, a cylinder is enclosed in the sphere of radius r. So shape is given. First one, when we read out the question, we need to understand what's the information given. Shape is given, and cylinder is inside the sphere. They ask you, you have to find out what is your dimension r and h. So what is this r and h? For the cylinder with maximum volume, so you want to maximize the cylinder. Therefore, in your information, your variable, so it will be the measurement from your cylinder. H is under H. H is the height of the cylinder, and R will be the radius of your cylinder. And then what is this R? This R is constant because that R is radius of the sphere. So container always fixed. You want to adjust your cylinder height and radius so that you can get the maximum. Maybe you can get taller cylinder or you get shorter cylinder. Who knows? So you want to try out which one reading can make you getting the maximum volume that you can get. So that is the first information. So we know that this is constant. Alright. Then secondly, we need to build out the formula. So what do you need here is formula about volume. Volume for the cylinder is pi r square h. And our formula must be in single variable. We have two variables here. So r and h. Look at r and h. What is the relationship that we can form out with this r and h? So this is the r. So we form out triangle. We can form out the triangle. So from the center to the perimeter here, this is radius for the sphere. So this h that we want, so totally height is odd. So the triangle here only take half of it. So this is h over 2. Alright, this is height of the cylinder, but we want this length only, so h over 2. Radius, still same. So for the triangle with 3 sides given, we can use Pythagoras theorem. So Pythagoras theorem says that a square plus b square equals to r square. Okay, a square plus b square equals to r square. Pythagoras theorem. Okay, then you look at the equation. So you're going to use r or use h. If you want to substitute r, we have ready made because r square can equals to this radius of the sphere minus h over 2 square. So remember, r here is constant. R here is constant means that is a number there, but we don't know what is that. We don't need to find out what's the number. We make sure it is constant. So we substitute r square here. The radius for the cylinder here is r square minus h minus 2 square. So this is a part of r square times h. So now we get our formula in single variable. Our variable here just remain h only. So to identify it to be maximum, we need to differentiate. Then we need to put two tests. So expand this, I get pi r square h minus pi, this one h square times h, which is h cubed over 4. Then step 3, we start differentiate. Differentiate v with respect to h. So respect to h, this is constant. So differentiate constant like 3h. Differentiate 3h, we get 3. So we get pi r square. Then minus here, differentiate respect to h, power move to the front, it will 3 over 4 pi h square. So after we differentiate, we find out the critical number, we let it to be 0. We need to find out what is your variable here, what's your critical number here. So 3 over 4 pi h square equals to pi r square, negative, negative, simplify, and some more, we can simplify pi. What do you need here is find out your h. It's not your r is constant. This big R is constant. So find out your variable h here. So h here is equals to positive, negative, square root for 4r square over 3. We simplify h. So when we simplify h, this is a height. We didn't take negative value because height will not have negative length. So we only have square root of 4r square. We get 2r over square root 3. Alright, square root 4r square, we get square root 4, we get 2. Square root r square, we get r. So square root 3 will still remain square. So this is our critical number. So after we get this critical number, we continue step number 4, doing the test. We test it out. d2v dh square, differentiate again respect to h. So this is constant. We differentiate constant, we get 0. When we differentiate this, power move to the front, negative 3 over 2, then power minus 1. Then we substitute h here. Negative 3 over 2 pi, h is 2r over 3. So obviously you can see this is negative value. Simplify, negative 3 over 3 pi r. So negative value less than 0 means concave downward. This is maximum case. So finally we managed to identify h maximum is 2r over 3. So what they ask you to do? So last step is answering the question. What they ask you to do? They ask you to find out the dimension R and H in terms of R when you have maximum volume. So I already verified you have maximum volume. So H maximum is this. Then what is your R? So radius maximum is what? So to find radius maximum, we substitute here. R square equals to R square minus your H here. H is 2R over 3 over 2 square. Alright, H I put in, then divide by 2, I put a new denominator. So 2 can be simplified. R square equals to R square minus here R square over 6. Alright, so some mistake here. So 3 square is 3, so I get this one 2 over 3r square and square root positive negative. So again, radius is a length, so we don't have positive, we don't have negative value. So I just have square root 2 over 3, and when we square root r square, I get r. So this is the r maximum that we can find. Then we continue for part B. Part B saying that find the ratio volume of the sphere to the cylinder with the maximum volume in its simplest form. So volume of the sphere, volume of the sphere, 4 over 3 pi r. The radius of the sphere, radius of the sphere is big R here, so pi r cubed. Meanwhile, volume maximum for cylinder, we need to find out volume maximum for cylinder, pi r square h. So pi, this is the r, pi r square, and then h. Alright, let me simplify first. This is pi, when we square, we get 2 over 3 r square, and then this is 2 over 3 r. So together 4 over 3 3 pi r cubed. Alright, so question asking here, ratio the sphere to the cylinder. So ratio the volume of the sphere means per volume of maximum cylinder. So 4 over 3 pi r cubed over 4 over 3 3 pi r cubed. We can notice here pi r cubed are same. 4 over 3 also same. Can cut it. So finally we get 3. 1 divided by 1 over 3, so 1 times 3, we get 3. Alright, so how to write it in ratio? This is our calculation. So ratio, write it properly. Ratio of the sphere, volume of the sphere, ratio to volume maximum equals to 3. Okay, so this is ratio means 2 dot here to 1. So denominator is 1. So 3 ratio to 1. Then we come up to this. How to score these 9 marks? So firstly, from the formula here, okay, how you relate your R and H using your Pythagoras correctly, 1 marks. Then you can get your equation in terms of H only. So this is your answer from your volume. In order to test it maximum, so you need the concept that you differentiate and you let it 0. Then you use second derivative. Alright, so this is your second derivative. This is your test. Second derivative to get the height and the radius. 1, 2, 3, 4, 5, 6. Alright, then find out your volume and do it in ratio. Write it in ratio. So that is the 3 marks here. So question A here is 1, 2, 3, 4, 5, 6 marks. Okay, so I think that's all for these questions.